Hey folks, welcome back to another video. Today we're looking at question 490, the maze. The way we'll be solving this problem is by using DFS. So as you know, for DFS, you need to keep a track of something that you've seen versus something that you've not seen. So let's get started with that, right? All right, so let's say we want to get the number of rows and columns. So let's say m rows, actually let's call it r equals maze.length. And the number of columns will be equal to maze of 0. So basically it means you're taking the first row and you're calculating how many columns it has. So it'll be maze of 0 dot length. Awesome. So once you have the dimensions of the maze, you need to create like a Boolean a 2D array. Let's call it visited. Usually I just call it v and then new Boolean, and you give it the same dimensions as the maze. That keeps a track of whether you visited a given node or not. So R and C. Now what do we need after that? I think that's the entire setup that we need. We'll actually be creating like a helper function, like you can call it like DFS, and which you can call recursively. So since DFS or even BFS are recursive, you need to be able to call itself. So since you need to be able to call itself, we'll create a method outside the hasPath method. So what does DFS need? So it needs maze. It needs the visited 2D array. It needs a start, where it's starting from. It needs the destination. What else does it need? Oh, I think this will be helpful. If you have like the number of rows and columns, you can check whether a given position is out of bounds or not. So that would be helpful. Awesome. So once we have that, let's actually set up the skeleton for DFS. So it'd be DFS. Let's take in all of the parameters. So int 2D array maze, boolean 2D array visited, int start, int actually yeah, int start, int destination. I just call it end destination, it's not long. And what do we need? Yes, int r and int c. Awesome. Once we have that, we need to check if a given, so the value that we're starting it with, whether it's visited or not. So let's actually extract the values. So int x will be start of 0 and int y. So basically the coordinates would be start of 1. Okay, so once we have the x and y values, what you need to check is if v of x and y, as in the given coordinates that we have, if it has been visited before, you just return false. As in, we don't want to do any kind of computation on this. It's basically been taken care of something that has already called it recursively, or we have explored that path already. Why is this? Sorry, this just caught my attention. And I think it's just lagging. Okay, so that's the first thing that we need to check. The second thing is, all right, so if x equals end of 0, basically you're checking if we have actually reached the destination or not, and y equals end of 1. The coordinates match, so you'd return true. Nice. So if these two cases are not returning, we basically need to keep moving, right? And for that, you need to move in 4 directions: up, down, left, and right. And to be able to do that, let's create like a direction. Let's call it okay. So basically, you can move up, so that would be 0, 1. So this is the x-axis. When you're moving up, the x-axis doesn't change. The y-axis changes by 1. If you're moving down, x-axis doesn't change again, but y-axis decreases. When you move right, x-axis increases by 1. Y-axis doesn't increase. And when you move left, it'll be -1 for x, 0 for y. Awesome. So the reason why we need this is because when we have a given starting position, you need to move in all of the directions until we hit a wall. So for int d in directions, right. So let's get move x would be equal to d of 0, move y of d of 1. Awesome. So this is the quantity by which we should actually move, right? So once we have a given like how much it should move by, we need to check a few things. So we need to check if it's actually within the bounds. So how do we do that? So we check not for if x plus mx is greater than or equal to 0. Yes, okay. So you're not adding it directly, you're just checking whether you can actually add it. Like adding it is still like a valid function. So you don't add it, but you just check whether the sum actually makes sense. So x plus mx is less than r. So how we imported r here. You could also, what you could do is you could just have like initialize r and c outside and then assign the values right here by extracting them. I wonder if it would have any performance improvements, but I'm not too sure, but it doesn't really matter for this question. So, all right, so coming back, so if we have checked that x is within bounds, let's do that for y plus my, if it is greater than or equal to 0. Now y plus my is less than c, and there's one more thing that we need to check. Right, so basically the direction that we're moving in, you can actually move in that direction, as in like there's no wall. And you also need to check that maze of x plus mx and maze of y plus my is not equal to, so spaces are represented, okay, is equal to, it's not equal to 1. Okay, so basically what we're saying here is that if it can actually move in that direction and it can continue moving, it's not even if, it's actually while, and I'll tell you why. Let's minimize this so that we can see everything in one direction. And okay, let's actually format this a little bit. Okay, so while this condition works, what you need to do is x plus equals mx and y plus equals my. Okay, so usually when you do DFS, it's usually, okay, check for one condition, as in like just if, and if it is, you just continue, you move it in that direction and then call DFS again. But the question clearly states that it keeps moving and it won't stop rolling until it hits a wall. So basically you need to keep moving in the same direction till it hits a wall. So that's the reason why we have a while loop here instead of just like an if condition. All right, so once you're done updating that, you actually call the DFS again. So DFS, you call that on maze. Okay, so and then we didn't mark that. Okay, so once we actually know that we haven't hit that, we actually need to mark those coordinates as visited so that we don't hit that hit those coordinates again and try to like loop it. If that happens, we keep running, the while loop will never exit. So yeah, so we've marked that, and then what are the things that we need to start? Okay, so it needs to and then x and y. Sorry, no, I think you need to actually create a new array. So new int uh, x and y, and then what else do we need? Start, and the other things don't change. Okay, so if this is true, if this returns true, you would just return true as is. Then return false. Okay, awesome. So I think that should be okay. Let's try compiling this and see if this is okay. Oh, right, of course, return false, not just false. All right, silly mistakes here and there. Okay, so the first test case is wrong, everything else is okay. Okay, so let's try walking through it, right? So this is a setup. We have number of rows, number of columns. We have the visited array, and then you pass in the maze. That's the visited array, start, destination, R, and C. Okay. So once you have X and Y, you extract them from the start. You check whether it's visited. If it is visited, you just return false. If it is the same as the destination coordinates, you return true, which is true. And then you mark that particular start coordinate as true. That's fine. So for the number of directions, m of mx plus my equals d0, d1, that's fine. So while m of x plus is greater than or equal to 0, less than r, y plus my is greater than or equal to 0, and y plus my is less than c, okay. And maze of x plus mx plus y plus my is not equal to, it's not equal to 1. You add, but okay, so while I'm thinking through this, we're changing the values of x and y, and these values, when you look at the other direction, when you look for other directions, the values of mx and my have changed. So I wonder if, I think this will fix it. Let's call it new x equals x, new y equals y. Yeah, okay. So basically, I think this is the mistake that I'm making. Okay, so let's just add n, 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 and then n, and then n, and then here it is ny, ny. Okay, let's try running that again. Okay, so the first few test cases have passed, everything else has passed as well. Awesome. So the mistake that I was making there is that basically I, instead of copying the values over for a given direction and keep moving them, I kept reassigning x and y. So that was a problem. But once we copied over the values and just incremented those values, it was fine. Awesome. So let's talk about the space and the time complexity of the entire solution. So the time complexity of the entire solution is m into n, because, for example, worst case scenario, there are no walls at all. We would have to go through all of the elements in the maze. And the space complexity is also m into n, because we are using an additional data structure, which is a 2D array, to store whether a particular cell has been visited or not. Awesome. So if you have any questions about this problem, please let me know in the comments below. Don't forget to like the video and subscribe to the channel. I would really, really appreciate that. It definitely keeps me motivated to make more videos. Thanks so much. I'll see you folks in the next video. Peace.